Hello and welcome to another nostalgic math chat. We are looking at IEB paper 1 from November 2023, question 7c. We are asked to solve for p if 3 to the power of log base p of 2 divided by 3 log base p of 8 is equal to 9. Okay, so there's a lot going on here, but the way that we chow an elephant is one piece at a time. Don't eat elephants. Right, so this is in a weird way an exponential equation, right? Because your p, your unknown, is in the exponent. So we're going to approach it the way that we approach most other exponential equations. You want to express both sides. Well, first I want to simplify this side so that it looks like 3 to the power of something, and then express the other side as well as 3 to the power of something, because once we've expressed it this way, then we can disregard the bases, right? If these two things are equal, it must be because these two things are equal, so then we can just focus on these guys. Right, so let's do that. Start with the easy side. 9 is the same as 3 squared. And then this side, the left-hand side, we can use our division rule that says if you have a to the x divided by a to the y, it's just the same as a to the x minus y. So this is the same as log 3 to the power of log base p of 2 minus log base p of 8, right? So now we've managed to make our bases the same, which means we can just look at the exponents. So log base p of 2 minus log base p of 8 must be equal to 2, right? And then our log laws tell us that if we have log base x of a minus log base x of b, that's just the same as log base x of a over b, right? So because we're working with the same base, thankfully, we can then rewrite this as log base p of 2 over 8 is equal to 2. Okay, whoopsie daisy. Right, there we go. Okay, so we have log base p of a quarter is equal to 2, right? And then we can use our knowledge of the relationship between logs and exponents to rewrite this equation, right? So we know that log base a of b is equal to k just means a to the power of k is equal to b, right? So likewise over here, p to the power of 2 is equal to a quarter, okay? We now have a quadratic expression, so take square roots on both sides. So, and remember it could be positive or negative, right? Yeah, there's nothing that limits this base from not being negative, I think. Right? No, not right. If I just think about the graph, so this would be something like a to the power of x, right? And then the log graph would be log base a of y is x, and that would look something like this. So, but that has nothing to do with the base. I mean, technically, the way we define our exponential function, we only look at a bigger than 0 and a not equal to 1. But that's not to say that the base can never be negative. The graph just wouldn't look this way. Okay, so I think both values of p, both p equal to a quarter or p equal to negative a quarter, I think both are valid. I don't know if there's a restriction there. Let's see what the memo says. The memo only looks at, Oh, and I've set up quarter. It's a half, sorry. Square root of 4 is not 4, it is 2. The memo says only the positive one. It only looks at the positive root. Interesting go. I guess maybe that's a definition of logs. P always has to be positive. P can only be positive. Let's double check that with the interwebs. Logarithm, can the base be, not the base, yes, the base be negative? No. This wouldn't give us any real solutions. Oh. So the base of a logarithm can only be positive numbers, excluding 1. Okay, so pretty much the reasoning that I was using over here, right? For these exponential graphs, we specifically talk about the base being positive or and not equal to 1. I'm not entirely happy with why. Why can't you log a negative number? Let's see what someone says. Someone in the midst. I can understand it not always having solutions. So if you have log base negative 2 of, I don't know, some crazy number, it won't always give you real numbers. The same way that negative 4 to the power of some numbers doesn't evaluate to real numbers. So negative 4 to the power of a half, you can't take a real square root of negative 4. So I get that, but I don't know. Okay, so it's not that it's not valid. It's just that we only consider logarithms with positive bases because they just work out nicely. Okay, anyway, so interesting adventure there. So we do not care about the negative over here because we don't like it, pretty much. So your answer would just be P is equal to positive a half.